Thanks for listening. This is Brian Hurley from Business Performance Improvement. The podcast Lean Six Sigma Bursts are short lessons, comments, Q&A, and insights. If you have a question, send your question through the Anchor app, and we might feature you on a future episode. Or contact me at biz-pi.com. I was talking to someone today about a project they wanted to work on, and we were going through and trying to figure out what the right metric was for success. And so this project has two key objectives. One is to improve the quality so that there's a higher success rate, less failures. The other one was to complete the task faster. So it takes over an hour in the process. They want to get it under an hour. So I asked about the current defect rate. I said, how many fail out of the total? And she said that they have 28 total that they have produced, and there were 3 failures. So basically 25 out of 28 were successful. That means it's around 90%, 89% to be exact. And so I looked at just a simple hypothesis test that would say, well, what do you need to get to in order to show a statistical difference? Because with only 28 samples, just adding 1 or 2 additional improvements adds a couple percentage points right there. So if you got to, let's say, 27 out of 28, could you even tell if that was statistically valid or not? So I ran it through Minitab and tried to figure out what would be how could you actually tell if there's a difference in those percentages? And at 27 out of 28, it would not be statistically valid yet. There's just not enough data points to pick that up. If you did 28 out of 28 and got perfect, it still would be a little short, a couple percentage points short of that. We look at something called a p-value, and this would be about 6 or 7%, and you want to get that under 5%. So we would need more data in the second sample, and you'd almost have to be at 100% success. Let's say you did 30 or 40 samples at 100% success rate. That's what it would take for you to be able to pick up a statistical difference. So what I suggested was to, maybe we still track that, it's important, but you're not going to be able to, I wouldn't use that as a primary number. Let's also use the reduction in cycle time as another metric. That gives us a little bit more measurement data, since time is a little easier to track and more granular than just pass-fail. Now, if we could look at specific parts of the failures and measure the performance of those failures somehow, that's measurable. Let's say there's a tolerance on these parts, and it's failing because the dimension is too large or too small. Then we could get measurement data, and maybe we could start to study that a little easier and pick up subtle differences. But if it's just pass-fail, you're going to need a lot more samples than if you have measurement data. So that's what I recommended, was to take the time data as maybe the primary metric, and we'll also track quality because that's also important, but knowing that we probably won't be able to pick up that difference in improvement, even if you got to 100%. So again, that gives a little bit of forecasting and prediction early in the project, just to kind of look at what would this look like? What kind of improvements would we expect? And this is a good exercise to also think about, what's it going to look like when I'm done with this project? What kind of numbers would I expect to see? And even starting to build out that chart before you even start the project, say, this is what I'm hoping to get to at some point. And then it kind of helps you see where you're trying to finish up. So almost like you're building out the results you want and then working backwards to say, now how do I get there? So that's another technique I like to think about, because ultimately that's what we're trying to do with these projects, is some metric has to get better. And so we need to be thinking about, what does that look like when I get done? And I've got a before metric of how we're doing and an after metric. And I should be able to see a significant change in the numbers from the baseline when I began to when I finished. Okay, hope that was helpful. If you have questions about maybe doing a project or something like that, please reach out through the Anchor app, or you can contact me through my website, biz-pi.com. Thanks. Lean6sigmadefinition.com has a list of glossary items about popular process improvement terms, along with a history of Lean and Six Sigma methods, and key influencers like Dr. Edward Stemming, Henry Ford, Taiichi Ono, Shigeo Shingo, and many more. You can also learn how to access affordable Lean and Six Sigma training and certification. Visit leansixsigmadefinition.com.